For years, the industry focused on a specific sequence of questions. Who launched the token? What is the supply? What does the roadmap promise? This model relies on metadata attached to a platform after launch, backed by creators who must maintain a narrative for the asset to hold value. When the creators stop updating the database or move on to a new project, the objects they built often lose their context. For a digital object to outlast its creator, it requires a foundation that exists independently of active human maintenance. It needs a record that cannot be edited or abandoned. To find that foundation, we have to look past the financial charts and corporate branding. Bitcoin operates as an environment, a terrain waiting to be explored rather than a brand waiting to be managed. This observation is the premise behind digital matter theory. Digital matter theory, or DMT, does not try to decorate Bitcoin with another token story. It analyzes the materials already present within the code. Shifting the focus toward discovery replaces the need for a marketing roadmap with a technical search of the data the network already contains. In physics, information never exists in a vacuum. It requires energy and a physical substrate to survive. Bitcoin data is not floating in a private database. Every block is produced through massive amounts of real-world power, time, and computational competition. This immense, unforgeable cost is what gives Bitcoin's digital objects a physical shadow. Proof of work functions as a security mechanism, but it also serves as the requirement for taking abstract information and giving it the weight of physical substance. To understand how this works in practice, look at this structure. It mirrors the physical periodic table of elements, but applies that logic to raw Bitcoin block data. The original periodic table did not invent oxygen or gold. It gave scientists a map to classify what the universe had already created. Builders using digital matter theory are doing the same thing by mapping the unalterable data already present on the chain. The elements in this system are data fields like block height, difficulty bits, timestamps, and the nonce. Because these fields cannot be changed once a block is settled, they act as permanent building blocks that can be isolated, searched, and recombined. Treating block data as elemental material reveals that Bitcoin has a rigid digital physics, independent of developer roadmaps or human interference. This elemental structure is applied through concepts like bitmap. Bitmap takes the sequential ledger of Bitcoin's history and treats the individual blocks as geographic coordinates. Structuring transaction history this way turns a linear ledger into a navigable spatial map. Within these spatial coordinates, we find non-arbitrary tokens, or NATs. These are the unique materials native to the territory. An ordinary token can declare any traits the creator chooses. A NAT must pull its properties directly from the network's constraints, such as a block's difficulty adjustment or its historical order. When an asset draws meaning from discovery under these network rules, it stops being a random collectible and begins to behave like true digital matter. Early experiments in any new category are often chaotic, but beneath the noise of individual projects, a structured asset class is taking shape. This framework of digital physics gives us an objective way to evaluate any new digital object. We can ask whether an asset depends on a promise from its creator, or if its existence is already embedded in the chain. This filter separates fleeting crypto hype from the permanent structural reality of Bitcoin native matter. Bitcoin's first achievement was giving the internet a permanent, ordered ledger for scarce digital money. We are now seeing that same base layer support scarce, recombinable digital materials. Understanding Bitcoin's physical shadow provides a map of the network's capabilities. It is a navigational guide, not a financial signal of what to buy or sell. True digital matter requires a permanent ledger, a high-cost structure, and a shared memory, all things Bitcoin already provides. The practice of manufacturing digital assets is being challenged by a model of uncovering and organizing the data Bitcoin already holds. Subscribe to the channel for more insights into the mechanics of digital physics, and we will see you in the next one.